Again, good afternoon all, and thank you for joining us for this talk on robotics in mining. This is a collaboration between a number of engineering societies. So I'm John Birchall and I represent the South African Council for Automation and Control. We reached out to the South African Institute for Mining and Metallurgy, the SIMM, a little while back, and we tried to find some ways for us to collaborate. And one of the obvious themes that came to mind was robotics in mining. Fortunately, we already had a connection with the Robotics Association of South Africa, and they pointed us in the direction of our guest speaker to lead the talk for today. So I would just like to give some thanks to Prof. Jan Stopforth, who is leading the IEEE Joint Chapter for Computer Systems, Robotics and Automation, as well as the Robotics Association of South Africa, for pointing us in the direction of Dr. Shaniel Davrajh, who is our guest speaker today, as well as the SIMM team, Camilla Jardine, Sam Muller, Setabili Madolo, and Gugu Charlie. Thank you so much for helping to arrange and coordinate everything for today. So before I introduce our guest speaker, please, while the presentation is ongoing, can you put some questions for us in the questions and answers field below? I will field the questions after the presentation. One correction, so on the LinkedIn promotion that went out for this event, I think it was in error stated that Dr. Davrajh is from India. He is certainly a South African. So sorry about that. Okay, and then on his background, he completed his PhD in mechanical engineering at the University of KwaZulu-Natal in 2015. During this time, he focused on developing prototypes of modular, reconfigurable manufacturing inspection robots. Having started his career as a lecturer in mechanical engineering, he transitioned to a position in mining engineering at the University of Johannesburg. Following that, Dr. Davrajh joined the Center for Robotics and Future Production within the Center or the Council for Scientific and Industrial Research, the CSIR. He also led the mechanized drill and blast stream within the Mandela Mining Precinct in 2018 and was involved with the development of prototype devices for the mining industry. Currently, Dr. Davrajh is involved in strategic development of project management for learning factories in South Africa, where the concept of human-centered automation is key. He is also currently involved in the development and implementation of a smart factory to support local SMEs. So thank you once again, and thank you, Dr. Davrajh, for taking this on. Over to you.
Thank you, John, and good afternoon to all the viewers. Thank you for making the time to attend this presentation. I'm just going to quickly switch over to video so you know that's a real person, not a robot presenting. And I'll get into the presentation quite quickly. I'm going to share my screen quickly. Please, John, if you can confirm that you can see it once I share.
Not yet.
Okay. Okay, so let's just have a look quickly. Okay, are you guys able to see that?
Yes, thank you.
Okay, great. Again, good afternoon, everyone. Just a disclaimer, sorry, this is a disclaimer before I continue, and that the work presented is based on my own research and experience. I'm not necessarily representing the CSIR. Also, the presentation or representation of robotic solutions is based on a combination of desktop studies as well as information gathered from site visits where applicable. I will be presenting some OEMs and research platforms as examples of technologies that exist, and I'm not in any way claiming to cover the span of offerings that are out there in the market. I won't only be focusing on robots in mining, but also touching on some automation aspects. And this presentation is going to be a general overview of robotics in mining, and I'm not going to go too technical into certain aspects, but I'll try to cover what I feel is sufficient for the audience. And any other questions that you may have or comments, I'll welcome at the end of the session. Okay, so to begin, a quick outline of what I'm going to talk about. I'll give an introduction or overview of robotics, mechanization and robotization, the application to mining, some emerging developments, additional considerations, the impact of robots in mining, and that's looking at the job side of things, as well as some concluding remarks. So firstly, what is a robot, and what do we initially consider to be a robot? And the formal definition is a robot that is a machine that can perform a complicated series of tasks automatically. But when we think about a robot, what comes to mind? Initially, when I studied robotics, we were taught about industrial robots and we classified them in terms of their configuration, etc. But nowadays, there's just so many different types of robots. And the trend now is to classify the types of robots in terms of their applications. So we'll start off with, for example, industrial robots, which include collaborative robots, automated guided vehicles, etc. There's consumer robots, and here you see an able companion robot, drones, UAVs, medical robots or robots for medical use, entertainment robots, robots for educational purposes, research robots, military robots, autonomous vehicles, and telepresence robots. In addition to this, there's also classifications of humanoid robots and underwater robots. And what I found is that generally this type of classification depends on the different standards governing the design and operation of these platforms. In addition to this, there's also robotic process automation, which is a form of business process automation that allows anyone to define a set of instructions for a robot or a bot to perform. So for example, the chatbot that you'd find on your Discovery app would be considered an RPA. So when we consider mining robots, then, is it simply any robot used in mining applications? The answer would be yes. However, we need to also consider that there's different areas of mining applications. So for example, drones can be used in mining. The research robot can be used in mining, and industrial robots can be used in mining as well. But does that classify them as a mining robot? And moving a bit deeper into it, my old professor always taught me that a robot is simply a set of motors and sensors that work together in some way, governed by some control architecture. And thus I came up with this, the layout of the key components of a robot, in terms of it needs a power supply, an actuation system, a controller, it needs a sensory system, manipulators or linkages, a user interface, communication interface as well, all coupled to some form of a base. And for those different types of components, we get different options. For example, in the power supply, we can look at electrical, hydraulic, pneumatic, etc. And there's different configurations of this, which can be assembled to meet a specific need. And that's where I'm heading with in the next slide, in that a robot is not just a platform that is designed in a silo. It's designed to work in an environment which has a specific need. And to describe that, we'll start off with firstly a working environment with a specific task that needs to be automated or robotized in some way. We then can follow a formal design process to come up with a solution to perform that task in an automated fashion. And then we can implement that robot. But ideally, what we're doing is we're having an ideation, creation, utilization process that's being conducted here. And one thing to consider is that the environment it works in will place certain constraints on that platform. For example, the operation side of things, in terms of the mode of operation, how would the robot interact with the environment? Would it be human operated? Would it be semi-autonomous or have an autonomous function completely? And when it comes to looking at different mining environments and the requirements for them, these sort of constraints need to be considered in the design of the platform, especially in cases where in remote circumstances, connectivity may be an issue, or tethered connections are not that practical, etc. There's also the maintenance consideration of that implementation that we execute. And an example of which would be in 2008 to 2011, there was a very big journey in terms of mechanization at one of the platinum mines, and maintenance or maintenance strategies not being suitably implemented was one of the causes for failures in that whole process. Just touching again in general on robot designs, what we find is that the trends in robot designs are moving now towards more modular designs, more configurable and reconfigurable designs, integrable or easy to interface, which talks to the last point here, fostering more collaboration across platforms. And for me, the most important one is where we can look at cross-application of robots across industries. And the reason for this is that different industries evolve at different paces. For example, the automotive industry adopts digital technologies much more rapidly than the agricultural sector or the mining sector for that matter. So can we then look at cross-application of technologies developed in the automotive sector being applied to these industries? And that's where I feel we can have a lot of value add in terms of quick wins. An example of a sort of configurable modular design would be the Lego robots or the Mindstorms. But a more commercial platform is the Husky platform available from ClearPath Robotics, which comes as a standardized platform, and you can put on it different types of, well, in this case, I believe it's a Cobot or UR5 or something like that. But we can also have it configured with different types of sensors to meet a specific need. But what I wanted to show here was that this sort of modular, configurable, reconfigurable thinking has found its way into the commercial space in terms of robotic design. In terms of mechanization and robotization, specifically with regards to mining, mechanization, the definition for it is any machine, process, or activity that reduces the human effort required to break or move rock or material in a mine. And in terms of robotization, the introduction of robots to carry out a mining task. But I found this interesting diagram here, which shows a transition in terms of energy required from the user and then the level of artificial intelligence or input control-wise from the platform itself. And what you'll find is that mechanization normally ends up somewhere around this point. And as we transition to the use of artificial intelligence, etc., we get to more autonomous platforms, you know, in general, in terms of the robot design itself. In terms of application to mining, why would we even consider robots in mining? Well, typically mining environments are capital intensive. They involve a lot of routine job processes, and there's a lot of health and safety issues associated with the job activities, such as you know, being exposed to or potential physical harm with moving equipment, etc. There's excessive heat, there's dust, poisonous smoke, harmful gases, etc. And what this does is it lends to mining environments being fertile ground for the application of automated solutions, where we can look at improving, first and foremost, safety and health, etc. Look at automating some of the routine processes. You know, one of the examples being driving of a haul truck and implementation of monitoring systems on that to keep the driver, you know, aware of their rate in the day, considering that they have to drive the same path up and down over and over, etc. So this is why we would consider it in general for the mining environment. And in terms of what's being done in Deloitte as a representation of future of mining, they look at this across the value chain. And in terms of automated solutions, they look at digitized geological data, which is not only the instrumentation or equipment to access geospatial information, it's also the systems that are required to process that information. So on one hand, now we're talking about the machine or the equipment, which is that robot or some piece or some device. And then we have the environment in which it functions, which needs to interface with that device in some way. And not only interface with it, but actually make sense of the information coming through. And I'll talk a bit more about haul trucks just now. autonomous equipment, which includes the haul trucks, IoT sensors for real-time data capture. But again, it's a challenge as to where do we implement those IoT sensors, and the data that is captured, does it actually relate or transcend into some physical, tangible productivity gain for the plant? That for me there's been a challenge in trying to track that and optimize that process. There's also wearables that exist in terms of field maintenance and operator safety. This includes technologies like augmented reality, virtual reality for training as well, but also wearables just for ensuring that the right person is there at the right time. There's also wearables for vitals, stats checking, etc. There's drones for inspection, stock and safety monitoring. And then we look at, in terms of the connectivity of the workforce through mobile platforms to make sure that the right person gets the right information at the right time so they can make the decision accordingly. Then we move on to the concept of digital twins in the environment, where we look at creating a digital representation of the mine. And this is to facilitate the optimization of any changes that need to be made to understand the impact of those changes on the overall operational performance. And lastly, in terms of looking at the integrated remote operation of systems, it's basically ensuring that, in terms of accessing information from a remote platform, etc., can be possible. An example of this would be the remote operation of automated drilling platforms in Australia, where you're able to control this platform from 120 kilometers away. All of that, though, hinges on the fact that there's a lot of data being generated, and according to Deloitte, there needs to be some form of digital mine nerve center which looks at real-time information, historical data, housing this information in some form of platform, and then using that to, as I mentioned, translate into some physical, tangible output that can benefit the operation of the entire process itself. So there's, again, these robots that are going to come into an environment, or automated solutions that are going to come into an environment, but there's also the overlying or overarching system that needs to manage these platforms, not only from an operational perspective, but also from a strategic perspective, to understand, what is the best solution for this specific point requirement in the value chain. Just a quick snapshot in terms of global robotics market in mining. This was a publication by Technavio, which released a report for 2018 to 2022. And they're quite positive in claims stating that the market for robots in mining will be accelerating over this period with a compound annual growth rate of over 27%. The other thing is that one of the key drivers for this market will be the increase in technology investment by the mining companies. And this is in efforts to improve productivity, more importantly, improve safety around the mining environments, etc. One thing worthy of note here is that they found that the market is fairly fragmented, with quite a few players who occupy the market share. And this lends to more sporadic point solutions that go to the cheapest vendor normally, as opposed to looking at things from a holistic perspective. In terms of the mining sector, this was some stats released by the Minerals Council for 2020, and that the mining sector employed about 450,000 people. They contributed about 27 billion rand in taxes and about 361 billion rand towards the GDP. And this is quite important when it comes to considering now, when we introduce more robotic and automated solutions to this environment, what impact does it have in terms of the employment of people, the number of people employed, the taxes coming into the system, and an overall contribution to the overall GDP. So sorry, moving on, then we'll start with some commercial platforms. And it'll be good to remember the components of the robot and view these platforms in that context. So I'm going to start now with materials handling and autonomous haulage in particular. And I'll start with the Cat MineStar command system, which has been documented to reduce operational costs of mines by claimed 20% and improve productivity by up to 30%. And this is obviously because it can run continually, it's reliable, it has sensors, etc. But it also has the ability to alert maintenance workers on machine problems. And this is because of the sensory components on this system or on this platform that have been implemented in a way to understand, firstly, what are the key areas or the key inputs to measure in relation to the KPIs you want to govern. And then also facilitate the system to transmit that or to facilitate that generation and transmission and processing of that information or that data to be able to translate it into improved maintenance of sorts. There's about 350 trucks like this worldwide, and they're currently embarking on a move to electric drive vehicles. Komatsu also has their offerings, the electric drive haul trucks, and they've been combined now, I believe, with their procurement of modular mining. And they've obtained the dispatch fleet management system, which allows for interaction between the loaders, graders, and dozers. And what this does is, instead of these different components functioning as individual entities, they can talk to each other and basically form a systematic approach or facilitate an optimized approach when it comes to integration of these different components into one sort of offering in terms of automated haulage. There's about 150 of these trucks used globally, and the system was the first in the industry to qualify to run on a private LTE mobile broadband technology in commercial operations. This was in 2019. Hitachi also came up with their automated haul solutions. And one interesting thing was that the company incorporated a permission control technique from the railway industry in its automated haul systems. And for me, this was quite interesting because it shows in the commercial space how technology transfer can occur across different industries. One of them being from locomotive to the mining industry. The next offering is from Scania, and they've developed a no driver cab and combustion engine, they developed a no driver cab, and their combustion engine derives power from renewable biofuel. And I thought that was quite interesting as well. Lastly, Volvo's also came up with a solution that runs on an electric battery drive system. And one thing that's interesting in terms of moving to electrification of these vehicles, it lends them more suitable to underground applications in terms of heat generation, etc. But there are ongoing challenges with these systems, and some of them recently have been noted as cybersecurity threats in the form of GPS attacks, which force these platforms to deviate from their true positions, and this leads to potential collisions. There's also camera attacks, which blocks out some of the cameras intentionally, potentially, again, causing collisions. There's also reliability of connectivity in some areas that poses an issue when looking at implementation of these systems here. And in terms of our layout or the sort of representation of what a robot is, it's improvements in the power supplies, the communication, the user interface, the controllers and the sensors that are sort of driving the development in this field. Then if we look at autonomous drills, there's Vale in Brazil, Rio Tinto, and then we have our own Kumba Iron Ore, which embarked on implementing autonomous drills in their environments. Vale has, I believe, currently, if they haven't finished it already, they're embarking on completing the implementation of 21 of these units. using the Flanders aardvark automation technology, coupled with or implemented onto Epiroc and Caterpillar. And one thing I want to point out here is that these platforms that they use weren't necessarily built for autonomous application. They were retrofitted for that type of application. And why that is significant is it shows that legacy equipment can be taken advantage of, or we can utilize legacy equipment with certain innovations in control technologies, etc., to facilitate this type of application. What that means then is that the CapEx, etc., gets impacted by this type of approach, and it relies heavily on the ability or the willingness for vendors to facilitate this type of collaborative approach, which I spoke about in terms of the trends in robotics. In terms of the Kumba iron platforms, it's developed by a supplier called Rosont. I believe they're in Midrand, and they are aiming to implement 28 of these rigs. Some reports say up to 30 at the site, but the goal is to do that by the end of this year. These platforms are prone to the similar challenges as the autonomous haul systems in terms of GPS hacks and cybersecurity issues, etc. Again, the sort of systems or the components that are driving the progression in this field for me are the communication, the user interfaces. And by the way, why I'm mentioning user interfaces is when we have predominantly a low-skilled labor force, the way in which they operate a piece of equipment needs to, or the equipment that we expose them to and the interface to that equipment needs to talk to that level of skill. So nobody needs to necessarily be a programmer, but they may be able to use some form of graphical interface to facilitate that interaction. Then there's advances in the controllers in terms of the execution and the accuracy or precision of the motions, etc. And then the sensors for providing feedback in terms of the GPS coordinates. I remember at one point they were talking about GPS accuracies of within 240 millimeters, and the drill bit itself was about 250 millimeters. So they were well within, you know, being quite accurate for drilling these holes, etc. Some additional offerings include some stuff that you guys would have probably seen before, reef miners, raise boring systems, etc. But one that caught my attention is an ABB Robotic Charger. ABB is a robot developer and supplier, but they got into the mining space as well with this platform. And this is a robotic charger which uses vision-guided navigation to locate holes that have been drilled and execute the charging process. There's also inclusion or the introduction of self-driving ore carriers. And in addition to this, not necessarily the platforms themselves, but the tools on the platform, such as smart cutters, are available, which in some cases can associate the changes in current draw to the hardness and potentially the characteristics of the materials being removed. And it can provide information on that. In terms of some local OEM offerings, we have CMTI MT3500 platform, which is remotely operated. One of the issues I know that previously were happening was in terms of staff using the equipment, were leaving the remote controls in you know, almost a waterlogged environment. There was damage resulted as, or damage occurred as a result. We have the RAM rock hauler, and then the Wetcrete robotic solution from Mel, which has some robotic abilities in terms of the spring of the Wetcrete, etc. Kindly note that I haven't been able to survey all the offerings of local OEMs, and I may have excluded some of them that may be relevant. So I do apologize for that. In Germany, we see a lot of initiatives happening in the research space, but it's transitioning more to the commercial side now. And this is one example, which is the Julius Robot, positioned to be an assistive robot. And this involves a robotic arm tipped with a 3-fingered hand. And what it does is it's capable of holding a scanning device very still, and it's able to analyze the quality of ore samples. And the idea for this is to have a symbiotic human-robot team where the robotic assistant contributes its physical strength, and the precision comes also from the robotic arm, but the human is in charge of decision-making ultimately. And again, the key components in terms of developments in these areas that drove this are the user interface, sensors, controllers, actuation systems, power supplies, communication, etc. This is the Alexander robot, which is part of a mining rocks project in Germany as well. And they're looking at developing platforms for autonomous reconnaissance of underground mines. And this uses the Husky platform that I spoke about earlier from ClearPath Robotics. It's equipped with vision sensors, environment sensors, etc. You can see the SICK lasers, etc. on this. And tests were conducted using this platform underground in 2 sections. The first section was a working section with rails. The second one, the ore drift. And the robot was able to generate a navigation map. It measured temperature, air humidity, air speed, and it tied these measurements to the generated map that was produced. And again, here we see how the actual collaboration in terms of the robot base merged with the inclusion of some sensors can provide for a quick win in this type of application. Another example is the UNEXMAN, which is an EU-driven initiative. It was developed to reassess old mines, most of which are flooded. And this is an autonomous underwater robot, which can function without remote control. The goal is to get it to function up to 500 meters without remote control or without any human intervention. It can potentially identify interesting minerals. And the purpose of this is to assist geologists in determining if further exploration is feasible. It consists of a flow meter, sonar, laser beam, and accelerometer sensors. And the project is still ongoing in terms of completing the tests for the proof of concept. And because it's a new platform, there were innovations that needed to happen across all these different components. This is a rail inspection robot. It's called SID, or Survey Inspection Device, developed at the CSIR for inspection of rails. I believe in 2018, there was a case where in Palabora, a locomotive collided with an elephant in the game park. And you know, a device like this or a robot like this that runs autonomously ahead of the locomotive could have helped prevent that type of situation. But it also helps in terms of preventing derailments. This was taken to a proof of concept stage where it could measure track gauges, etc. And it was tested on some rails for Transnet. But application to the mining industry is potentially there. Then lastly, in terms of drones, drones have many applications, both on surface and underground. I'll talk a bit about the surface ones, where we look at stockpile management for better inventory and financial data, better forecasting of mineral stock for sale, for example. Then we look at minor quarry monitoring and operation planning for haul roads and water and sediment flow. There's assessments before and after drilling or blasting. There's hazard identification and mitigation. And lastly, mineral exploration. And again, here, it's the changes in these different mechanisms or components that enable this type of development to be commercially available and implemented in the mining space. Then in terms of some emerging developments, this is some results from an analysis done by Boston Consulting Group, who have a branch in South Africa. They looked at what's already in use in terms of big data, real-time data, logistics, and blockchain, and they looked at digital twins, which are already being implemented at different mines or different operations. They looked at real-time data being implemented for predictive maintenance. The logistics side of things, the solutions existing there, and then the application of blockchain to sort of validate the transactions that occur within the value chain, across the value chain. Then they also looked at some of the close to commercial use in terms of interconnected sensors, and that's looking at the drone side of things, but looking at performing in situ scanning. There's advanced analytics, and some of the challenges come in where, for example, you get autonomous trucks that generate 1 terabyte of data per day. And it's nice to have a system that can generate this data, but sometimes it becomes so much and we don't know what to do with it. And there's so many systems that generate this type of data. In one of the mines we visited, there were 293 independent systems feeding information. And it became very difficult to track the application or facilitate the incorporation or transition of that raw data to some physical, tangible improvement in the system. And then also in terms of close to commercial use, there's applications of quantum computing to handle that big data and for looking at planning route optimization. An example would be for the haul trucks, and a good application would be for looking at dispensing suppressant for dust suppression and optimizing that process. If you can equip those trucks with flow meters and you can optimally dispense the suppressant, you could also have an idea of what the cost is going to be at the end of the month. Typically what happens is that the suppressant gets dispensed, and then the contractors bill the company at the end of the month saying this is what you owe us, without any sort of feedback or method to validate that spend. Then we also look at market intelligence in terms of digital channels that expand arbitrage opportunities. But there's also research that's being done across the globe when it comes to different types of robots and applications of robots. I'm not going to go too much into this because of time constraints, but I believe that this presentation will be made available and you guys can read through this. This was just to show that there is ongoing research. And moving on then to further work by Boston Consulting Group. We have the challenges that they've been looking at identifying, where companies say that they want greater collaboration between IT and users. The data is insufficient or inaccurate. The solutions that come in are standalone or work in silos. And there's a lack of a well-established digital upskilling program. So when we incorporate these solutions, there's not enough, or there's an insufficient skills base to address that. Sorry, I'm just gonna. Sorry, guys, I must apologize for the background noise. Of all days, people decide to move offices today. Apologies for that. Sorry, where was I? I was talking about the insufficient approach. Again, sorry about that. I have to tell people to keep quiet there. Okay, sorry. So I was talking about the lack of a well-established digital upskilling program, where we want to incorporate or bring in these automated solutions, bring in these robots, but we don't necessarily have the skill sets to adapt to that or to operate and implement those solutions. And that poses a challenge as well. So some of the transitions that they've proposed here are that we need to focus on the operator focus on the operator needs to close the strategy execution gap. And then the second one here, where they say value data as much as a physical asset, I do agree with that, but it's about understanding firstly what that data is. And if you cannot relate it to some physical improvement in the system or some operational improvement in the system, then it's not really valid data. So in terms of valuing the data, it's actually identifying which data to value first and then valuing the data, in my opinion. And basically here, what I looked at in terms of what needs to happen is some improvements in terms of the systems or the controls that we have, the communication side of things, and the user interfaces. And I'll talk about that quickly. I've got a nephew who he's 2 years old, and he can unlock my smartphone and go to YouTube and watch his videos that he likes all the time. He doesn't need to know how that smartphone works, but he knows how to use it. He's only 2. Similarly, when it comes to a platform that we implement and we look at introducing new types of robots or different types of automation systems into the environment, the interface to that environment is very important, because the level of worker that we will be addressing in that type of environment is typically low skill. But they don't need to know the inner workings of that platform. They just need to know how to use it, and that interface then becomes very promising. What I'm going to do now, and I'm not sure if I clicked. Sorry, I'm not sure if I clicked share sound. I'm just going to see, and I'm hoping that you guys can hear the sound, but I'm just going to. How do I stop sharing here? So do I stop sharing? Okay. So I'm going to move to the next slide, and I'm hoping you guys can hear the sound clip. John, if you can confirm whether or not you hear the sound clip when I start playing the video, I would appreciate that. This is a solution that has been provided by Boston Dynamics. It started off as a military vehicle or a military robot to assist with carrying certain payloads for the military for the military force.
Shaniel?
Hi, John.
Sorry, I can't see anything. I can't hear anything.
Okay, no, I didn't play it as yet.
All right, no worries.
Okay, yes, the platform was developed for military applications, and the core contribution of the company came in the control systems for stabilizing the platform. And, you know, they could go over quite rough terrain. And this platform now is available for something like about 75,000 euros, if I'm not mistaken, or dollars, sorry, $75,000. There is a licensing fee associated with that, but I think it could be a quick win when it comes to serving applications for the mining industry. And you're going to see why just now as I play this video. So John, if you can just confirm when I play this.
We can hear and see.
You can hear it. Perfect. Thank you.
Mine is an ultra deep mine in northern Ontario, Canada. We mine metal, so copper, zinc, silver, and we're one of the deepest in the world, closest to the center of the earth. We're a large operation with large equipment, large openings like the one behind me here that we need to inspect on a regular basis. So when it comes to this type of mining, the most important control that we have is to create distance. So everything we do here has to be at some kind of distance from hazards. So in this particular case, we're looking at inspection, and inspection is something we have to do every day as part of our job. Typically, we have to go to fairly great lengths to do it. So right now, that means using very traditional style robots, even wheels on sticks. As primitive as that may sound, that's common in the industry. Tools like this can get us right up and close and personal with the things that we need to see. Currently, when we're trying to get information in these type of locations, we use small tracked robots that we can carry around easily as part of our normal work. And we need to ask a lot of our operators to come through here and clean the areas, clean the floors and so on so that we can get in. But what I've seen with Spot is that it's been able to pass anything that is normally left without any real special care to make it accessible. I actually found out about Spot through some people that I work with down in Sudbury, a group that specializes in technology underground, things like drones and road exploration. And that's what led us to this point where we are testing Spot underground. I was quite impressed to see how it can handle different types of terrain. We have a fleet of tracked and positional wheeled robots that we use underground, but there's nothing that compares to the way that Spot steps or moves around objects and moves ground and other types of material. I see a really big advantage when it comes to Spot, and that's the distance and the duration that we can take on with it. So that means that we can put our people very far away from a hazard, and we can get in and get the information that we need. When it comes to engineering-driven mining like we do, it's really based on data. It's driven by our ability to get information on a regular basis and turn it around so that we can make good decisions based on that information. So having a tool that can quickly, reliably get into everywhere that we need to get information and bring it back to us is invaluable to our business.
Okay, so you guys get the point of that video. And hopefully you see the value add in that in terms of search and rescue operations or also surveying operations. I think that could be a quick win, and it's a commercially available platform. It already has all the sensors on it, and you can order it in a very customized fashion. I believe the University of Johannesburg has just procured one. So anybody in the mining field that wants to explore this opportunity can get hold of the guys from UJ to facilitate something like that. I am aware of time, so I'm going to be rushing through this next few slides. In terms of robotic process automation, what we see is that typically automation finds its way into the finance and control systems, or when it comes into production, there's a bit of caution and incremental implementation when it comes to the core mining functions and implementing it in there. What we find though is that when we do introduce sort of these disruptive changes or robotic processes or automation at any level, there's going to be a shift in the skill sets required from the workforce, and that we'll need a higher level of skilled employees. The number of unskilled employees will reduce. The level of productivity per employee will be expected to improve. There'll be a number of new skilled positions increasing. Safety is expected to improve. The workforce costs are expected to improve because you're going to be paying higher salaries, but bear in mind that obviously you're going to be paying less people. And the overall production costs are expected to reduce. That's when we look at this type of an intervention. But in addition to that, in terms of the workforce impact, you've got to look as well as the systems that need to be in place to facilitate this type of adoption. And here we have to look at things like data lakes and data islands, etc. And there's certain challenges associated with that need to be considered. And looking at the impact of mining, the first bit, the question that's going to be most asked is, will the introduction of robots cause job loss? And the answer is yes, inevitably it will at some point. And the argument is always that automation or robots will cause more job creation in another field, etc. But if we look at Uber employs much more people than large-scale manufacturers and mining operations. I'm talking about individual companies. The number of people taking metered taxis because of the introduction of the Uber platform has reduced though. So there were jobs displaced in that field or that industry. So yes, there is going to be that type of job loss, even though there may be creation of more jobs, but ultimately there's going to be this type of job loss. And the example I'll give is that, you know, we can say we can expect people to move on with the digital revolution and become data analysts, etc. But if you have a 50-year-old rock drill operator who's done the same task for more than 30 years, it's very unlikely that they'll be able to transition to that position of using AI or becoming a data analyst. So there we need to look at other options, and I'll explain the possibilities just now. But touching back on the South African, or the slide on the South African mining context with regards to the contribution to GDP and taxes, etc. When we look at introducing robotics and automation, there's going to be a change in the job trends. There's going to be a change in the salaries and ultimately income taxes as well. How much impact will there be as a result of this? It's almost impossible to determine at this point. It's conditioned by many aspects, including policy regulation. And also we have to look at it on a case-by-case basis because different companies will have different strategies, different levels of automation or robotic implementation as well. Sorry. But again, going back to this, this diagram here, as we transition more towards the use of artificial intelligence, we'll find that the requirement for more skilled jobs is going to increase, but then the low-skilled jobs, which is the bulk of our workforce, we need to consider what's going to happen to them. So what can be done about this? Well, we can look at reskilling, upskilling, and cross-skilling. And you know, there's an example here of a coal miner becoming a mobile robot technician. But I go back to that case of the 50-year-old rock drill operator. What can we do with them? If there is going to be such a type of displacement ongoing, then we need to look at other options such as reskilling them, upskilling them, or cross-skilling them specifically to be absorbed in a different sector, perhaps. So, for example, they could work in the agricultural sector, they could work in the manufacturing sector. Those are potential solutions for that type of displacement. It's not really, you know, a very convincing solution, I would say, but it is a possibility that we will need to explore. And, you know, this definitely needs to be looked at on a case-by-case basis. There's no generic answer for that, unfortunately. Sorry. We can look, sorry, the last point I've got here is that we can look at easing or making the operation of technology much easier. I gave the example of my 2-year-old nephew who can use his phone, use my phone. That's because the interface to that is so easy to use. So we can look at that as a technology change. So concluding, in conclusion, for me, there's no silver bullet in terms of there's no one robot that's going to really change the face of mining per se. I've shown you one that has potential to improve the situation in some cases, but that needs to be tested. We need to look at incremental gains, therefore, and this has been ongoing for quite a while. We need to break down the silo mentality and look at cross-application of technologies, learn from other industries where possible. And I spoke about bringing in what's being done in the automotive sector and applying it possibly to mining where applicable. We need to take advantage of developing technologies such as 3D printing. One of the problems is that when you got legacy equipment and you don't have suppliers anymore and spares are in short supply or non-existent, we need to start looking at creating that value chain, and robots can contribute to that as well. We look at changes in materials in development. There's improvements in battery technologies, operating systems for robots, etc. I mean, we haven't even touched on that, interfaces, etc. Then we need to look at also skills development platforms to address the local skills gaps, and we need to focus on keeping humans in the loop when it comes to certain applications. Europeans focus mainly on, using machines to replace human labor. We want to use machines to create human labor, and that's what we should be focusing on. But obviously, when it comes to aspects that are very dangerous and safety is paramount, we will have to look at full automated solutions. There's additional considerations as well that we haven't touched on in detail, such as cybersecurity, energy monitoring, etc. And the last note I've got here is that robots are tools, even artificial intelligence. How we use them actually enables leveraging of improvement opportunities. So it's not just about the one solution, but how we use it and the system we develop in implementing that solution that actually provides the impact to the environment. Lastly, I'd like to ask this question, and just so I can also learn from the audience themselves. The 4IR is already here, the changes have already begun. Are we willing to wait out the challenges in terms of trying to look at, international solutions coming into the space, or can we in some way become proactive with the focus towards the impact? And if so, how? How can we do that? What are the quick wins we can look at, implementing? What are the challenges to implementing localized technologies? What are the challenges with localizing those technologies? And there's a lot of fantastic work being done by our local OEMs, the universities, research organizations, the research institutes within the mining faculty itself. How can we leverage off of that And how do we coordinate all of that? I know there are initiatives like the Mandela Mining Precinct, which looks at coordinating such types of activities. But how do we have this impact, and what's the barriers to this success? So with that, I'd like to say thank you all for your time. I do apologize for the background noise. I'll leave it open to any questions or comments. Thank you, John.
Thank you, Shaniel. I can still see your slides. I don't know if everybody can see me. We've got not that much time left. We've got a couple of questions that came through. So maybe the first question from Sugashan Pillai. I'm sorry if I get the pronunciation wrong. The question is, what preventative measures are in place to prevent incorrect user usage or machine malfunctions? I don't know if you've had exploration on that in your research, Shaniel.
Yes, so most of the times, and looking at when I was interviewing local suppliers, local OEMs, we came across situations where mining houses would blame the suppliers or the OEMs for failure of an equipment. And the OEM would say, well, you guys aren't using the equipment properly. So what needs to happen in that? And the best solution for that we came to in terms of the most practical one was that there needs to be a champion that's driving the entire implementation process or the integration of that machine into the work environment from both sides. So there needs to be a champion from the OEM side and a champion from the mining side to take responsibility. And when I say that, I'm saying that the OEM champion needs to look at, okay, fine, do we actually meet the needs of this environment and this skill set of labor? Or and the mining operations champion needs to look at, have we trained these staff sufficiently to integrate this piece of equipment into our environment? It's sort of like I draw an analogy between this and dropping off your kid at school. Nowadays, parents expect that school is a one-stop shop for life, and students are expected to learn life lessons at school. And parents have almost minimal to no interaction with their kids whatsoever, because they're expecting the school to do all the work for them. And the analogy is that the mining house expects the OEM to meet all their needs, and the OEM expects the mining house to take responsibility in terms of having the correct facilities available, the correct maintenance strategies, the correct staff available. There's also solutions of contracting where people have moved over from OEM supply to actually contracting the equipment out or leasing the equipment and supporting in that basis. But the best solution was that combination of champions from both sides. Thank you, John.
All right, excellent. Thank you. All right, I think there was one question that did come through on the actual chat. Let me just find it. I think it was from Walid Palmer. He was curious about what these autonomous haulers and trucks that you mentioned, are they actually operating in South Africa? And if at all possible, can you share where?
I believe, I don't know if the name is still there, but Finchmine had quite a few of those. If I'm not mistaken, there were 3 of those vehicles running for very, I would say, limited distances in terms of their operation. I know there were some weird issues happening back in 2016 where they changed tire sizes, and this caused collisions because the actual encoders were reading wrong linear distances, things like that. But yeah, there have been examples of that. Yeah, and that's one example.
Thank you. And there's 2 more questions. I know we've run out of time, but for those that can stay on, you're welcome. Okay, from Nkosipi Nyandu. Okay, so it's a long one. I'm worried about job losses after the introduction of robots. Did you, in your research, obviously at the end of your presentation, you came to that, Shaniel, but did you in your research come across where the balance is between an interest of the employee as well as the employer? And then the state will obviously lose revenue. I think he highlights the risk or the impacts of robots. And then finally, the difficult part is that the robots will be imported. So in other words, there will be almost a shift towards importing instead of actually labor internal. So I'm not sure, Shaniel, I think if you understand the question, or there's a question you can answer there, I think maybe the question would be is what are we doing to identify and to treat this delicate political situation internally?
Yeah, I would say my response to that would be that any company embarking on some form of digital transformation needs to take into account all of these different factors. You can't just buy something for the sake of buying it and implement it willy-nilly. You have to understand the impact that it's going to have. That's why a lot of our leading mining companies do undergo quite an extensive feasibility study when it comes to digital transformation, because they understand the socioeconomic impact that it's going to have. However, you must understand that if these companies do not embark on these digital transformation journeys, the life of mine is going to be much shorter than it could be. The whole goal is to optimize that process. And unfortunately, like I said, there is going to be job loss, whether we like it or not. But ultimately, there will always be job loss if the mine shuts down anyway. So it's about trying to preserve that life of mine and trying to do so in an optimal way for a certain period of time. And then they look at it over, maybe 10 or 20 years, as opposed to everyone keeping their jobs now and nobody has a job in 2 years' time. So definitely a lot of consideration goes into this. And I've been exposed to a lot of that, which I can't really divulge at this point. But definitely we have to give credit to the mining companies where it's due.
So maybe just a follow-up from my side on that. So there are initiatives ongoing to take on this upskilling challenge that lies ahead.
Yes, there are. One of the initiatives that we are embarking on is looking at the development of a learning factory in collaboration with the MERCITA. And it looks at competency development as opposed to a formal qualification. So you want to create competencies or enable the development of competencies for the workforce. And we focus on low-skilled, the low-skilled labor force, and teaching them how to operate and implement certain technologies like drones, collaborative robots, primarily because the interface to these technologies has been so simplified that even kids nowadays can use that. So definitely that's one facility that's could add value to this.
Do you have maybe a contact point for industry or people who would like to reach out or learn more about that? Is there something you can point us to?
In fact, yes. So I'm actually managing that facility, and they can contact me directly.
All right. Thank you very much. There is one more question. I think it disappeared, actually. I think it was just a question around how students, if there are students online that are particularly interested in this field, maybe can you recommend a way to enter this space? What would the approach be? Where would they go?
Depends what their students are, but typically if they're mining students, then I know at the University of Johannesburg, they have a lot of work integrated learning programs that they have strong links with different mining companies. In fact, I know all like VETS and UP, etc., have very strong links with the mining houses, and students can go and get experiential training in that regard. But let's assume now they're from another field. I would suggest then try to talk to people in technology areas within that field and identify firstly what you would like to learn. And there are a lot of initiatives and support programs out there by the mining houses themselves. And there's a possibility of contacting them directly.
Right, excellent. Thank you so much again, Shaniel. Thank you for taking the time and taking on the topic. And thank you for everybody that stayed on. I think most people stayed on. We lost only about 4 people near the end. And yeah, thank you again, everybody that made this event possible. So yeah, feel free to contact the organizations that arranged this directly if you would like to get involved in the organizations in question, or if you would like to explore the topic further, maybe we can help you chase down the relevant stakeholders or the people that can answer the right questions. Thank you so much.
Thank you very much, John. Cheers, everyone.